Hi everybody! So today we're going to be talking about the chemistry of sunscreen. And in case you're not already sold on the importance of sunscreen, here's an actual photo of me at the beach for the first time as a baby. And here is another real picture from that same trip after my ghostly flesh had actually been exposed to a little sunlight. All joking aside, sunscreen truly is a useful product. But before we can get into how it actually works, we need to start off with a few basics. First of all, what is a sunburn? Well, it's different from the kind of burn you get from touching something hot, like a kitchen fire. Any elementary schooler can tell you that the sun is hot. But it's actually not the sun's heat that burns our skin. When the energy from the sun's ultraviolet radiation penetrates our skin cells, it can cause damage to important cell molecules like DNA. DNA controls what type of proteins our cells synthesize, so when DNA is damaged by UV light from the sun, skin cells start to produce special proteins called prostaglandins and cytokines. These proteins trigger an immune response, causing cutaneous blood vessels to dilate and inflammatory cells to gather. This immune response is actually the reason we experience the swelling and the redness. So, now that we've got that straight, let's talk labeling. You've probably heard of UVA, UVB, and UVC rays, but what's the real difference between them, and why do we even care? Well, the actual distinction between the three types of rays has to do with the different wavelengths of the ultraviolet light. The different wavelengths mean the three types of UV radiation have different effects on human skin. Although UVB rays are primarily responsible for sunburns and most types of skin cancer, UVA and UVC rays can also cause serious damage to the skin. Thus, it's important to recognize that SPF, or sun protection factor, only refers to how well sunscreen protects against UVB radiation. So, even a high SPF product could still leave you exposed to damage from UV light. This is why you're always going to want to look for sunscreens that are labeled broad spectrum to make sure you're being protected from multiple types of UV light. So, now that we've got down the basics, let's talk about the chemistry. How does sunscreen actually work? Sunscreen depends on a combination of organic, that is carbon-based, and inorganic, or non-carbon-based compounds. The inorganic compounds act as shields which physically reflect UV light away from the skin. Meanwhile, organic compounds work more like sponges, absorbing UV rays so that our skin cells don't have to. On its own, one very commonly used inorganic compound, titanium dioxide, which is pictured here, would actually create carcinogenic free radicals in the photocatalytic reaction. So, to prevent this, the titanium dioxide molecules that are used in sunscreen are first coated in silica or alumina. In addition, newer sunscreen formulas use titanium dioxide nanoparticles rather than the full bulky compounds to give the optical effect of transparency, so that the sunscreen we use doesn't have to appear quite so pasty. At the same time, organic compounds such as para-aminobenzoic acid, or PABA, protect our skin by absorbing UV light and dissipating it as heat. But how do they do this? Well, when molecules like para-aminobenzoic acid have the ability to form resonance structures, the electrons within the molecule have a lot of freedom to move around. The electrons in PABA happen to move in time with the wavelength of UVB light, thus allowing the PABA molecule to absorb the energy from UVB rays before later releasing it as heat. Knowing how resonance relates to the function of organic UV absorbers, we can then design molecules to absorb different types of UV light. For example, benzophenone, which has a longer chain of resonance bonds, can resonate at longer wavelengths, and thus not only absorb UVB, but also UVA rays. When designing sunscreens, chemical engineers are not only looking for molecules that absorb UV rays, but also that will mix with oils in the paste, rub on clear, resist washing off, and still not irritate the skin. Anyways, I need to wrap this video up. So, in summary, I'm pale. Sunburns are caused by skin cell DNA damage from exposure to UVB radiation. SPF only refers to the product's efficacy against UVB rays. Inorganic compounds in sunscreen block UV light, while organic compounds use resonance to absorb it like a sponge. And woo, that's all for today. Thanks for tuning in.